Okay, great. If you haven't grabbed a lollipop, we still have a few in front. Feel free to grab one or more. Thank you so much for coming in such a rainy day. This morning when I was parking in the UNSW car park, I found it very, very easy to find a parking spot. So I kind of had an idea, like we have like students coming on campus today. So thank you so much for coming. Have a lollipop, get something sweet, and we'll get started with the lecture today. Before we start is the audio going on? Okay. Before we get started, I want to respond to your feedback from week 1 and week 2 first. First of all, our lecture code has been shared. You can find the link on our forum. So I posted like 2 days ago after our Wednesday's lecture. So you can see a link to our lecture code. It's here. So for now, I've uploaded the lecture code for week 1 to week 3. Some of the code from today to the end of week 3, the code will be updated after the lecture. So I will be coding, like doing some demo during the lecture, and the code will also be updated. And I will also push the changes after the lectures. You can also follow along the lecture if you like, because you have the code now, and if you want, you can also follow with my demo. So this is the code. Another thing, another feedback we got from the QR code is, I'm wondering how's my lecture speed. I constantly check if you understand, if I have any question during the lecture, but I'm still not too sure, should I be slower or should I be faster? So I created this poll. If you can scan this on this QR code and let me know whether I should be faster or slower, that would be very helpful. Active. It should be active now. Too slow, go faster, okay. Speed is okay, good. Good, being okay, yep. Too slow. Okay, the data is still coming in. Thank you so much for your feedback and okay, I think the trend is clear now. So either okay or too slow. So I was afraid I was being too fast. It's especially when I was talking about JavaScript. I was afraid I'm being too fast. But now I'm more released. I'm not being too fast. So that's good. Okay, so this is to respond to the feedback. And for those of you, we still have 50% of students who think I'm being too fast. For those of you, we have lecture recording. So this is what I always do when I was a student. I will replay those parts. I think the lecture was too fast. And then I will pause whenever needed, and I will do some practice following the demo and make sure that I understand everything clearly. During the lecture, I might also take some notes. I want to recap on this concept after lecture, or I want to recap on the other concept, so that I do not need to replay all the recording from the beginning to the end, so that I can know where I was lost during the lecture. Cool, great. What else? I also received some feedback about wanting the forum to have anonymous feature like it did in 1511. We also received the similar feedback from previous term. The reason that we disable the anonymous feedback is because we do not want to confuse you, because the anonymous feedback feature on the ad forum is not real anonymous. So there's still ways like we can figure out who is posting what. So that if you have like anything that you want to ask in private, you can choose the private posting or private option on ad forum, so that only the tutors and the lecturers will be able to see your question. So no question is stupid. So none of us know everything. This is for true. So sometimes you think it's a stupid question, but for us, I think you are asking a very, very good question. So no question is stupid. So this applies for both forum as well as like in the lectures. If you have any question, post it on the online chat or like just raise your hand and ask. So no question is stupid. So you do not need to be afraid of that. So another reason that I can think of, like people are asking for anonymous questions, because you want to ask some like confident thing, like maybe about your tutor, like you do not want your tutor to see that. I'm not sure. But if you have that kind of concern, you can always email the course account so that myself and the admins can see your email only. So your tutors will not be able to know that. So just in case you have any like conflict with your tutor, you can always email cs1531@csc.unsw.edu. And if you want only myself to know it, you can always email me. If you do not want anyone, including me, to know what you want to say, you can always scan the QR code at the end of the lectures. So that one is real anonymous. Okay, so if you have anything that you want your name to be known by anyone, you can scan that QR code. Okay. Other feedback. Again, we received the feedback on how to use the Linux system, like how to edit text file. I will show that again today. I hope that'll be helpful. Like I would assume that people know how to use terminals. So this is my assumption. So I went pretty fast with the terminals. I also shared some resources on the ad forum earlier this week, but like shared a YouTube video. I think it's a pretty good one, introducing how to use terminal. Where is it? Yep, I shared some resources earlier this week on how to use Linux system, like how to use the text editors. Other feedback that we got is asking to put the lecture slides as a PowerPoint. I'm not sure why. Maybe you are more used to PowerPoint. I will try to. The reason that we use the way that we have now is because we have a lot of code in the slide. And yeah, and the code got updated when I was editing in VS Code, so it synced the process. So using PowerPoint cannot help us with that, but I will try to figure out a better way to share the lecture slides with you if I can find any. But if you have any suggestions, you can always let me know. Yeah, good. And if you are in general confused about anything that we mentioned in the lecture, there are a lot of ways to get help. I think earlier this week, we have a couple of help sessions was quite empty. So if you need any one-on-one help, you can jump on the help session. Okay, at least this week, I think it's not, it's like well staffed, at least this week. Okay, yeah, so that's my response to your feedback. Thank you so much for your feedback again. It will let me know how I can improve, and I can also learn like how you want me to deliver the lecture. Okay, cool, great, thank you. Any question online? Nope, good. Okay, so today the first topic that we'll cover is about correctness. Let's have a look at all the lecture contents. So today is the first lecture about correctness. By correctness we mean testing. We want our code to do what we want them to do, like give the correct outputs, do the correct behavior. So this is what we mean by correctness. But actually, we are talking about testing. We'll do a lot of testing in this course. You may wonder, why do we need to devote this kind of effort onto testing? Like writing testing code takes a lot of time. I believe my code works well. Why do I need to devote so much time onto testing? Why? And in industry, it also costs money, like time costs money, right? So why do we need to care about testing? So testing is actually about quality control. So quality control is important not only in software engineering, it's almost important anywhere. Like when you are building a house, you want your house to be of good quality, right? You do not want to live there for more than 5 years and then thing starts to crack, right? So quality control is also important in software engineering and in softwares. So in some extreme cases, a bug or like a defect can degrade the interconnected system or cause serious issues. Some examples. So Nissan they had to recall over 1 million cars due to a software defect in the airbag sensor detects. So, so this is an example of why quality control is so important, and we want to do good testings before we launch the software. And another software bug caused a failure of $1.2 billion for the military satellite launch. So this costs a lot, much more than the money or the time cost for writing the test suits. Right? So this is why testing is so important. The numbers speak for themselves. No more questions online. Okay. And a successful test shows that your system operates as intended. So for example, you want your system to calculate for you the sum of 1 and 2. And you do not want your system to return something random like ABC. Right, so this is in basic what testing does. So put testing in a more broader context. We had a very brief introduction of software development lifecycle in the very first lecture, and we'll go through this lifecycle again and again and again during the lectures this term. And now, so far we've talked about the development. To some extent, we talk about JavaScript, like how we write code, like write functions. So that was about development. And now we are talking about testing. So testing is also an important part in the software development lifecycle. We want to make sure our application does what it is supposed to do. And in this lifecycle, the testing is after the development. But in reality, the testing doesn't always only happen after development. We'll see later today, why and how. Yeah, and there are also many tests, many different tests of testing. Can you think of one type of testing? Yeah. SDLC is software development lifecycle. Yes. Yeah. Good. Cool. Can you think of any type of testing? So imagine you are developing a software. What do you want to test? Yeah.
User testing.
User testing. What do you mean by user testing? You have the person to use the system?
Yeah.
Yep, that's a way of testing, have a user to use your system and you observe them using the system and see if they struggle to find anything or use anything and ask them for feedback after the user testing. So this is user testing. Any other ways of testing that you want to use for your software? Yep. Oh, sorry? A bug testing. Yeah, testing if there's any bug. Yep.
It's like going through edge cases.
Edge cases. Yep, that is right. Yep. Anything else? Yep.
System testing.
System testing? Yep. What do you mean by system testing?
Like testing how programs work with each
Yep, so there are multiple components in the software, so you want to make sure that the components work well with each other, right? Yep, anything else? Yep, all of the ways of testing are correct, like there are a lot of different ways of testing. So I listed some of them here, and most of them has been already mentioned by you. So for example, acceptance testing. After you have developed your software, you want to make sure whether it works what it's supposed to work. So this is acceptance testing. And integration testing is actually what they just mentioned about the system testing. You want to make sure that different components can integrate well with each other. So this is the integration testing. And unit testing is something that similar, like testing if there's any bug, like for the functions or for a small module, like the unit testing. And usability testing is the did you say use testing? Yep. So the term that we use more often is called usability testing. Like whether it is easy to use is called usability testing. And functional testing, performance testing, there are a lot of different ways of testing. But we are not covering all of them in this course. We'll pick some of the ones that are relevant to the fundamental course in this one. Okay, so software testing concerns with exercising and observing product behavior. So we may have some test data. So for example, that example we gave earlier, like we want to know the sum of 1 and 2. We want to make sure it's 3. So this is the test data. So 1 and 2 is the test data, and we want to make sure it's 3. So we feed in some test data. We may also design some test cases and design some test data to put it in our software and see if the supposed behavior or output is given. Cool. So today we'll be focused on the dynamic verification. Verification performs during the execution of the software, and this is often what we mean by saying like testing a software or software testing. And typically, dynamic verification will fall into one of the two categories, testing the small or testing the large. So this is true. Yep. Yep. I should have put this slide earlier, but it's okay. So testing shows the presence, not the absence of bugs. So what we mean by this one. So for example, you design some test data, right, and you feed in your software, and you get all the output correctly and what you expected. Can we assume that there's no bugs, no errors in our software? No, right? However, if there's any bug, like we know there are bugs, but if there's no error showing in our test suite, it doesn't necessarily mean that there's no bug. So this is what we mean by this code. So in real world, like there's always something like bugs or invalid inputs or unexpected data. So for example, we designed a system to help people calculate numbers like 1 and 2 equals to 3. However, users may not use your system as what you built the system for. So they may input something like A and B. So we need to have like test suites for those unexpected data inputs. Also, maybe for example, you designed something and you assume there may be like 10 or 100 people using your software. However, the software was too good, so good, like 1 million people use your software on the first day, and everything got cracked. So there are always like unexpected things happen. So we need to test things as much as we can. Yep, so we want to make our program robust in face of real and inevitable things that go wrong while a program is running. And there's also a long-term benefits of having a testing suite. So when we have a software, especially when the software is very successful. It will live for quite a long time, and we'll make changes to it. So we want to make sure that our change do not break our software. All right, so you have a testing suite. You have a so like 1 and 2 equals to 3. Whatever you change in your sum function should never break our like testing. It should 1 and 2 should always be 3. So having a test suite ensures that when you are making changes to your software, you know if there's anything broken. So people forget things, but tends not to. Check online. Yep. So let's start with testing in small. The smallest. So the small testing, normally we're referring to the unit testing, like a function in your code base. Like you have a sum function, you have calculate the length of your array, the length function. So this is unit testing. But sometimes unit testing can also be referring to module testing. Like you have a set of functions and they together forms a module. And unit testing can sometimes also referring to module testing. But now we only referring the unit testing to like testing a function, like the small testing. Like testing particular functions in isolation. Am I being too slow again? All good? Yep, there are also testing in large. We may have a couple of functions or a couple of files together, and they do a simple thing or relevant thing. For example, about downloading. And we want to put them together as a black box. Like we do not want to know what are the functions inside that. What is each line of code in each function? We are not interested in that. We're only interested in put everything together as a black box and make sure like with things input we get the expected output. So this is what we mean by black box. So testing in large sometimes include module tests. So this is a bit like the term we use. So sometimes in unit testing we also include module tests, but sometimes people like separate module tests, and they also have a more larger scale testing called integration tests, like testing integration of module, like putting a couple of modules together and testing them together. And there's also system testing, everything together, tested the whole system as a black box. Well, in like a small project like 1531, the major project, we cannot have this many layers of testing because the project itself is not big. But if in a real world, like industrial project, it can be very large. So they may have different layers of testing, like start from the smallest, like testing each function, like gradually larger, broader scope, and then at the end they have like system tests. Okay, so let's try to write some tests. Here you are given a function called getEven. So given an array, numbers, and in them maybe they have 1, 2, 3 or 1, 3, 4. And you want to loop through these numbers and push the even numbers into these evens, and we return evens. Yep. What are you going to do to test, like without any knowledge beforehand, like before we talk about testing? How can you make sure, or how can you prove yourself your function is written correctly? Yep. Run it. Let me run it. Oops, let me close this one. My code. You can also have the code, like if you want to follow with me. Yep, so this is our code. So you say run it. Okay, so I'm going to, here's my terminal. Am I in the right folder? Yes, I am. So I'm going to run it. So 2.3 even testing 1.js. Remember, like we run JavaScript code by using node, following the file's name to run. Nothing returns. So can I know? At least there's no bug or error message return. That is good. Yep. Any thoughts?
I kind of tested it.
Yeah, like you have written this code. Like you want to make sure it's written correctly. What are you going to do?
Oh, we can paste it into ChatGPT.
Oh, feed it into ChatGPT. Yep, this is something we can do. Yep.
We just like add some console logs into the file.
Yep.
Like test cases.
Console log. So what are you going to put in that?
Call the function.
Call the function get even, and
Whatever you're talking about.
whatever I can put in that. For example, 1, 2, 3, like that.
Yep.
Okay, let's run it again. Cool. Looks like it works fine. Yay. Any other thoughts? How can you make sure your function is written correctly? Yep. Sorry? Check if it's valid.
No, test invalid inputs.
Oh, test invalid inputs.
Put things like A, B, C.
Yay, that's a good idea. Let us have a try. A, B, C. And then let's run this code. Yay, error message. Great. Yep.
If you make them like characters instead, they're names.
Make them as
Like put them in as strings.
put them in as strings.
Yeah.
Okay. Yep. So it kind of works well, like return an empty array, like when we feed in ABC. However, imagine like you have a large code base, and when you are testing, you got an like empty array. So how did you know whether it's because the original array, like the testing set that you given, there's no even numbers in it, or because people put in some like random ABC or stuff? So that's a good point. Yep. Cool. So we can have more testing cases. Like we can check whether they are ABC, like they are the strings, or whether they are valid 1, 2, 3. So we can have a lot of test cases. However, they are good, but they are more like debugging. So sometimes we debug in this way, like we console log something and we check whether the output is what it is expected. Yep. So we want to have something more scalable, especially when our code base size is getting larger. Yeah. So printing errors or visually inspecting output is a method of debugging instead of testing. So we cannot call something a testing method if it doesn't scale well. Yep. Black box. So a great type of testing relies on testing abstractions. So we talked about black box before. So abstraction is, think of the black box as abstract something. So we do not look into the details. We look at the abstracted one. Like we do not worry about the underlying details. So we actually, in real life, we do this all the time. So when we want to buy a bicycle, we just try it and see if it works well. Like we want to buy a second-hand one. Like we do not inspect everything, like the wheels and all the details and everything. We just try it on, right? We just try it and make sure it works. And same with like cars, like we do not inspect the engines. Like we have little knowledge about engines. So at least me, I have knowledge about that. So I will just try it and make sure it works. So the same applies to testing. Like we do not need to look at the exact code. So sometimes we can even have other people write the testing code for us. So we do not need to look at the details. So when we are testing code, we want to view the functions we are testing as abstraction. So for example, this one is called blackbox.js. You can also find that in the code base like I shared with you. So this is the two functions that I want to test. There's nothing in it. So there's no single line except the return 0. So how can we write testing? We can still do what we just did, like console.log, what is it? Remove walls, put in a string, like A, just A or ABC, and we see how if A is removed after we call the remove walls. So we do not really need to know any details about what is inside of the function. And same with the calculate the factorial of the numbers. Yeah, we can even do one step further. Like we can console log remove wall and see if it is equal to B and C. If it returns true, means that this test case is passed.
Put another equal sign there.
Oh yes, you are right. Thank you. Yep. Okay. So this is what we mean by blackboard testing. Like we do not look at how the function is written. We just treat it as an abstraction, and we can also write the test first before we write the function itself. So we can have a set of test cases, for example, this one, and we can have more, it's too complex. B, C, D, A. And it should be something like that. So we can try like having the walls at the beginning of a string, at the end of a string, or in the middle of a string, or we can have multiple walls in a string. So edge cases we mentioned earlier, like testing. We can also test multiple edge cases. Okay, so actually in reality, most of the time, we also encourage you to write blackboard testing, meaning that you write the testing before you write the function. So we'll encourage you to do that. There are a couple of reasons for that. First is when you have written the function, you might be biased because you know what are the edge cases that you considered when writing the function, and you test those edge cases only. So it can be biased. Also, the test cases sometimes may also coming from the documents from the other team. So the other team who get requirements from the clients, so they may have specified what this module or that function should work like. So the test use may coming from the other group of people, like not us developers, but also often the tests also are written by the developers. But writing the test before writing the function can help us avoid the bias when writing the test, comparing with writing test later. Yep, so we already had that. Cool. So now we mentioned that we want to make our testing scalable. So how can we make that scalable? So we are introducing Jest. To test at scale, we need a real testing framework. And Jest is a popular framework for JavaScript, and it can be installed with NPM. You may have a couple of questions with this single line. So first of all, what is framework? What is Jest? And why is popular? Why we teach this Jest in this course? I will answer them one by one. So in the Tuesday lecture, we learned about NPM. So NPM is it's very powerful for JavaScript. Like we can use the code written by others. Like we tried the data function during the Tuesday's lecture, right? So people have already written the function, a set of function for data functions. So it's a library that we can use directly using NPM. In addition to these libraries, there are also frameworks that can be installed using NPM. So frameworks is often confused, like what are the difference with framework and libraries. So framework is also a code base that you can install using NPM. So it's also some code written by others that you can use directly so that you do not need to write your own testing framework. Like you can write your own, of course, but there may be bugs and it's also time consuming. So there are well-proved, like well-used framework you can use directly. So framework comparing with library is more of something, you can think of it like a tool. Like library is something that you can call in your functions, right? Like you can use the other codes in your functions. But framework may call your function. Still a little bit confused. It's okay, I will explain during the demo and you will know what I mean by that. So Jest is one of the popular framework for testing JavaScript. So let's have a look at Jest first. Here. So Jest is a JavaScript testing framework. It works with Node, like Node.js. And they also have very good documentation that you can refer to, like starting from how to install it, how to use that, and why we learn Jest in this course. So Jest is not the only testing framework for JavaScript. However, it's getting more and more popular and used by more and more people in industry. So it's popularly used in industry. So we teach industrial practice in this course. So this is why we learn Jest. So you can see that in 2021, there have already been 73% of JavaScript users use Jest to test their JavaScript code. Okay, so let's now try to install Jest and see what happens. Similarly, we use npm install, but the difference here is we have the --save -dev. Before I explain, I will just execute that. So you can see that the installing process is very similar to what we did like when we npm install date function. The process is pretty similar. However, we have the this one here. So what does it mean? It means that Jest will only be the dependency that be used during the development and the testing. So there are 3 environments. So this is not a little bit outside the scope of this course, but I assume that people will ask, so I will explain that. So there are a couple of environments in the development process. So we have the development environment. We also have the production environment. So production environment is the environment that you put your code for production. Like the users will use the code, like they will execute the code in the production environment. However, there's also the development environment. Like you put the code, like the random testing cases, like random code or something like in your development environment. And testing is also here, like at least unit testing, just testing is put in the development environment. So you do not want to put like all the code in the production environment. Like people will execute code and sometimes will cause issues. So when we npm install framework or library with this safe dev, means that this is the dependency only to be used for development and testing. And it's not to be used for in the production environment. So this is why. Okay. You can also see the difference in our code base. Like here's the package.json file. Last lecture. Yep. Remember the last lecture when we npm install the date function, the dependency was added here. Let me install that again. Npm install. Is it date function? Is that right? Yep. I return. Yeah, so you can see that date function is added here under dependencies. However, our jest is added under the dev dependencies in the package.json file. So that in this package.json file, it specifies which dependency is only installed in the dev environment, like it installed as the dev dependency. So you can see the difference here, right? Okay, cool. Any questions so far? All good? All good? Okay, cool. Great. So let's try an example to use jest. So we had jest lib. So you can find the jest dash lib in the code base. So so we want to have another file to write our jest test. So to be able to call the remove wall function in another file, remember last time we mentioned that we need to export it first. We need to export this function to be able to import and use that function in another file. So we export remove walls. And yeah, a little bit overwhelmed looking at that. So I will remove those first. So this is how our jest testing file looks like. So we first import this function from this file, and here is our testing set. And under the umbrella of remove walls, we have a set of testing cases. The first test cases is that we want to test the strings with no walls. Okay, and we expect the example one, like BCD, after remove wall to be equal to BCD, so nothing changed. A little bit confused here, right? So what are these? What is describe? What is test? What is expect? What is expect to equal or whatever? So this is the structure or the syntax, like we read jest test. Let's try writing one together, and you can get a feeling of how it works. So the first step we had was test string with no walls. let's write something, for example, strings with only words. What about that? With only words. And A, E, I, O, U. Is that right? Remove words. And that it should return, it should be nothing. So what is expect to equal? What does that mean? Expect example 1, so remove word of AE, to equal. It's just what it means, like to equal an empty string. Yep. Cool, great. Thank you. We can also have more like test strings start with words. So for example, A, B, 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 and I, D, 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 and it should return B, 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 and D, 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 right? Yep. And we can have, what else? What are the other cases that we want to test? Sorry?
Like a mixture of
Vowels
vowels and not vowels.
and not vowels. Yep, a mixture. Strings mixed with vowels. Okay. E, O, and it should be B and D, D. Any other cases you want to test? That all? Yeah.
Empty strings.
Empty strings. That's interesting. Okay. Empty strings. Empty strings. Is that right? Okay. Now we have written the test, but we haven't written any part of this function, remove words. The way like we run jest test, like we can run it before we write any part of the function, is by using something that you may think is weird at beginning, but I will explain. So the way we run it is something like this. So what is that? I will explain. But you know what is the second part, right? So this is the test file that we want to run. 2.3 jestlib.test.js. We are not at the right folder. Yeah, so this is what happens when we run the jest test. So you can see there's a lot of errors, fails, because we haven't had anything in the function, right? So this is normal. But you can see like we are running jest. So we actually run jest like npm, or we use node. So it's different from libraries, right? So libraries is something like we use in our functions, like a function we can call in our functions. But jest, although it's also downloaded from npm, also installed from npm, but it's a framework. It calls our functions. It's on top of our files or our functions. So framework is different from libraries, but they are all of them, like both of them, are code base that written by somewhere else, and we can use directly. Okay. Okay. So now let's go back to this. So what is that? So node modules .bin jest. Are you tired? No? Okay. Cool. If you are tired, feel free to grab a lollipop, and I hope can bring you some energy. And we'll finish the testing part, and then we'll have a break. Okay. So what is that? So you can see that using terminal, again, we are trying to access this folder, and in this folder there should be something called jest. Okay, so now let's have a look at my folder here. I'm going to node.models, and there should be like .bin, and in .bin there's a jest. Can I see clearly? So it's here. Oops. So it's under the folder node modules. Under that folder, there's a folder called .bin. And under .bin folder, there's something called jest. Right? So this is why we had node modules.bin.jest. And then we run this .test.js file. So you may ask, like, what is this .test.js file? So we have seen .js file. So what is .test.js file? So .test.js file is where we store our jest tests, the code for the jest test, like this one we just wrote together. And jest will find those .test.js files. Okay. We got a question from Ali online. When do we need jest package? Like when doing iteration, or we can download now? You can download now. Like we provide you the lecture code. You can git clone the repo, and you can install jest now. So this is something that you can practice now. However, it may not work in your lab 2 or your project iteration 0 because the environment is not set for jest testing. But you can practice with lab 0 3. One of the lab 0 3 is about practicing jest. So you can use lab 0 3 to practice what we learned today. But iteration 0 will not work with jest testing yet. Thank you. Okay. So we have seen like expect to equal, but there are also more than that. I attached a link in the slide, and there are also other ones like expect to be, expect to be now, expect to be undefined, and also expect to be greater than, expected to be less than. Just provide a well-documented files like that. And they also provide a pretty good explanation. I think most of them are pretty clear. Expect the difference between expect to be and expect to equal. Any guess? Yep.
What about describe?
Describe.
Yes.
It's the thing. Okay, so this is also a good question. It's here. So a describes umbrella. So under that, all of this text under that is about remove walls. You can have another describe. So for example, if I copy this, if you're tired, we can have a break and come back. Otherwise, so we can have another describe. If, for example, we have another function that we want to test, for example, sum function. And under that, we can have test suits for the sum function. Is that clear? Yep, okay. How's your first week going so far? For 1531? Good? 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 Yep. Any of you struggling with Git? With JavaScript? It's absolutely no shame struggling. I know some of you have some experience before with Git or JavaScript, but some of you have absolutely no experience with that at all. So it's absolutely fine if you are struggling. Sorry. So I know that, like myself, when I first come to Git, come to JavaScript, I was a little bit overwhelmed myself. What I found very useful is practice. So watching the lectures is useful, of course, but it doesn't help with everything. So practice. So practice is really what helps. The labs, they are very helpful, and also the group major project. So the labs are helpful for your major project. But to practice using Git within a group, within a software team, like we need to have a group of people, like you cannot practice by yourself. And if you work in a team using Git, if you start to find issues here and there, and you assume you know everything, but when you're working as a team, working with others, you may find like, well, I do not know everything, so that's absolutely fine. So if you are struggle, that's okay, we are just in week 2. It's just week 2, we just started. We still have plenty of time, I hope, to prepare and learn. Okay, cool. So we stopped at here, like how we run JS testing. Yep, we had those. Yeah, we had testing on complex word, like the mixed one. Strings with ending walls, starting only, no walls. Okay, great. We also even add one with nothing in the string, like empty string, which is great. Cool. So now just something else we can do. So in this JSON file, like package.json file, in last lecture we very briefly demoed how we can add scripts here. Last time we tried something like hello 1531, and then we echo hello. Did you remember what happened? Oops. Yeah, we print out hello in the terminal, right? So we can add scripts there. We can also add something. For example, we have test, and we can have. Oops. Where is it? The one that we just run, which is this one. We can also put that in our script. So we can have test and this command line that we run on the terminal. So now we can do, for example, we can have npm run test. What do you think will happen? Sorry? Yes, it will run the .node that line. Right. So let's have a try. Yes, it does. So it really saves our effort. Like we do not need to have those long line again and again. We just put a script in our .json file. So you may also wonder, what if I want to test the different files each time? Like this time I want to test the js.lib.test.js, but next time maybe I want to run JS for another file. What we can do is we can remove that in the JSON file, and we can, like after npm run test, we put the file name here, and we return, it will do the same thing. So next time when you want to run JS, what you can do is npm run and test. The reason that we have npm run test is because we had in the JSON file test here. Like it's just a name. You can also have something like JS test. It's the same. But to simplify things, we just run test. Okay, so this is what we can do. Even further, we can also remove this. We can just have test ... and then just and source file. So the SRC is the folder that I had all the source file. And npm or Node.js, like they can find this jest within the .bin folder automatically. Okay, so this is something that we can have to make things easier. Okay. Yep. Questions? Any questions? All good? Okay, so now let's write something for remove walls and investigate the output from npm run test. How can we write remove walls? Any thoughts?
Wait, can you, are strings just arrays of characters in JavaScript as well? So could I do like four letter of string, and then like if it's a vowel, just delete it?
Yep, that's very smart. But I'm going to do a more silly way, which is string and string dot replace. So there's a string method or string function called string replace. So we have seen array functions or array method like array dot length, right? Array dot push. So this is something similar. It's called string dot replace. What we want to replace is a, e, I, o, u into something empty. Right, so we can repeat that. Repeat, a, e, I, o, u. A, e, I, o, u. Question?
Are we expected to know all these methods?
The question is, do we expect to know all of these, like dot replace or dot push or dot something? The answer is no. I only know very few of them. The way I found like whether there's anything is by searching online. Like I want to find something to remove something, like change A to empty, or I want to change something, I search online and I try things. So I try and see if it works. Yep. Okay. Now we had that, and we also I will remove this second describe. So we together we wrote this test file. So now let's run npm test again and see what happens. Oops. npm run test, and this is the file that I want to test. Oh, they passed. Great. How? Huh? Yes, I think there should be some. Okay, maybe our test file is not that complete. Yep, question?
That's with like 5 A's.
Sorry?
Like A.
5 A's. Yes. So this is what I was expecting, something to go wrong. So we should have one more test case. So this is often why it's quite hard to write a very complete test suite. So there's always some edge cases like we forgot to test. Okay, so when we like the output that we just saw, like everything is passed, doesn't mean that our function is 100% correct. Maybe there's something missing in our test fields. Okay, so let's write all walls strings. And we have a and e. They should also return empty strings, right? So let's run the testing again. Yay, failed. Okay, it's fine. Like it's helpful, like to find something failed. It's helpful to help us find some bugs or some edge cases that we didn't consider in our code. So let's have a look what is wrong. Like all wall string failed and all the other test cases succeed. Okay, let's have a look. So what was expected is an empty. However, we received an A. Right? We fit in a 5 A's and received we fit in a 6 A's and returned a 5 A's. So we removed only one walls. So there should be more walls being replaced. So it's called replace all. So now let's try again. Yay, it passed. Yay. Yep. So this is also why testing is helpful. Like we may assume like replace can replace, but it doesn't really replace all. It only replaces the first one. Okay. Yep. So this like you also asked the question like what is describe? So describe a like broad area that you want to test. Like for example, you have multiple functions. Under one describe, you test one function or one relevant area, and under that you have different tests. Yep. Tests for each property or use cases that we are looking at to test. For example, here, under this test, we only test strings with no walls, and under this test, we only test strings with only walls. So this is helpful because when we saw the output from jest, we can see like all wall strings. So this one didn't pass. So we can know under which scenario the jest test was failed. So this is helpful for us to make changes. We have a question online. Why there is a single quotes after walls in string.replace? Did you mean here? So in JavaScript strings, single quotes and double quotes are the same. So there's no difference. Yep. Okay. Kitten asked online, in this case, which is better, using for function or all? What did you mean? Did you mean describe? So, like describe an area like we want to test. The question was about replace all. So difference between replace and replace all is replace one, only the first instance of seeing a wall, like seeing A or E or L or U. But replace all replace all of them into empty. So delete all of them. Yep. Cool. There's also a more. Oh, we stopped before the break at here. So the in the jest test we had expect to equal. So expect like BCD to equal BCD, or expect 2 to equal 2. So this is quite straightforward. However, there's also one very similar syntax in jest test, which is called expect to be. So what's the difference between expect to be and expect to equal? So we can also see here, like expect 2 plus 2 to be 4. It's still true, it's still nothing wrong. We also had expect to equal, and we have an array with, it's an array, or it's an object with called data with 1 and 2, and we had to equal. So what's the difference? Can you, yep.
Is one of them like double equals, the other one triple? So like 2 equal is the 2 equals, and 3 is the 3 equals.
Interesting, yep. Any other thoughts?
To be should be used for primitive objects, or primitive types like integers and doubles, and to equal should be used for complex objects like arrays and objects.
Yep. Yep. I think. So to be is more useful for comparing whether to like strings or numbers to be the same. Like 4, like expect 4 to be 4, or expect A to be A. However, when you try to expect an array of 1 and 2 to be an array of 1 and 2, you will get something wrong. They will say array 1 and 2 is not to be array 1 and 2. The reason is that like two arrays, 1 and 2, 1 and 2, the values of them are the same. But there's no two arrays or two objects are identical. So they are still two arrays, although the values in them are the same. Does that make sense? Yep. So to be test identity. So they're identities, and to equal test the features like the values in them. So we can think like twins, like two twins. They look very similar to each other, but they are still two persons. Yep. So this is the difference. Okay, we have already seen. Yeah, we can also have describe and describe. It's just like the scope. Like under a big scope, there's a smaller scope, and under a smaller scope, there are smaller scopes. Yeah.
Does that mean you had two identical arrays, but if you did two equal, they would bring out true?
Sorry, can you repeat that?
So if you have two arrays,
Uh-huh.
same values,
Yep.
2b would say they're not the same.
Mm-hmm.
2 equal,
Mm-hmm.
would that say they're the same?
Yes,
Okay.
that's right.
Oh,
Yep.
So if 2 equals used for like an array, what if it's 1, 2, and 1, 3? Will it still be 2 equal?
What? Sorry.
If it's like if an array has 1, 2,
Uh-huh.
and then we combine with an array that's 1, 3, would that still give out 3? Because the
1, 2 cannot be equal to 1's array.
No, because isn't 2 equal used to compare between objects?
Yep. So to equal is more useful for objects and arrays, if that makes sense.
Why can't 2b be used for arrays and objects? Because if they're the same, then 2b should not be here.
You mean, I still do not understand your question. So there's no two arrays or two objects are identical.
Okay.
Yeah.
So why can't we use 2b? Because if we use 2b, we can compare if an array is 1 and 2,
Uh-huh.
the other array is 1 and 2, we can use 2b, right? To compare them. Because
Then you will receive a false.
Oh, why is that?
So because although, yeah. Did you? Yeah, of course.
Okay, in JavaScript, objects and arrays are passed around by reference. You know what reference is? So by pointer. So when you do like, if array 1 to be array 2, it will check the pointers, and they point to different arrays, so they're different.
Oh,
What to equal does is that it goes to the array and it checks every element inside the array.
Right.
So to equal works for arrays.
right. Yeah, makes sense. Thank you.
Thank you. Yeah, I also found that when the peers are explaining to the peers, it's often more like easier to understand. Like you, like kind of have more similar background and knowledge base, so it's easier. So that is great. Thank you so much. Also, like in your groups, I also found like teaching each other can also be very useful. Like sometimes I feel like I understand, but I think I explain quite clearly, but still sometimes students cannot really get what I said. So yeah, so it's really good, like we can learn from each other. Nice. Okay. we a little bit run out of time. We still have a second lecture. Okay, so design by contract. I'll be fast. So sometimes when we have we want to have a function, before we write anything in that function, there may be some like external requirement for that function, like we mentioned earlier. So we write the test first, following the contract, like the documentation of what function needs to achieve. So we follow that contract or follow that documentation, and we write the test. If it makes sense. Yep. Last slide. Testing can only show the presence of errors in a program. It cannot demonstrate that there are no remaining faults. We have seen that in that demo. Okay. Yep. Ooh, amazing.